Flying in the United States has become less of an adventure and more of a draining routine. Anyone who has traveled frequently in the past few years knows this feeling. You build in extra hours just in case. You race between terminals when a gate suddenly changes. You sit through maintenance delays that always seem to be labeled temporary. And even after all of that effort, your flight still arrives late. This isn't just a rare frustration. In 2023, government data showed that nearly 1 out of every 5 flights across the country failed to arrive on time. At the same time, ticket prices have remained stubbornly high. A big part of that comes down to fuel, which still makes up around 30% of airline operating costs. That single factor forces airlines to keep fares inflated, while continuing to tack on more add-on fees for checked bags, early boarding, or even choosing a seat. What we're left with is a system that grows more expensive and less reliable for the average traveler each year. It's no wonder people have started asking if there's a better way to move forward into that frustration steps. Elon Musk and Tesla. And what they're suggesting could reshape aviation in much the same way that Tesla reshaped the auto industry. The focus is the so-called super-electric plane, a fully battery-powered aircraft with a price tag of $79,979. That figure instantly raises eyebrows because it suggests affordability on a level the aerospace industry almost never delivers. But the bigger story is not just the plane itself. It's the way Tesla plans to build it. Instead of copying the decades-old model of traditional aerospace giants, Tesla wants to apply the same playbook it used for cars. Solar systems and energy storage, a modular, scalable production process that slashes costs while boosting speed. Tonight, we're going to pull apart that production plan, exploring how Tesla intends to lower expenses, accelerate output, and ultimately test whether this project could truly upend the airline status quo. At the center of Tesla's idea is modularity. In traditional aviation, airplanes are built in an almost artisanal way, with countless custom-fabricated components coming from suppliers scattered all over the globe. Each plane can take months, even years, to roll off a line. Tesla's approach is completely different. They want the airframe, the body of the aircraft, to be broken down into large, simplified modules that can be produced quickly and then assembled with precision robotics. Think of how the Gigapress revolutionized car manufacturing by casting giant chunks of a vehicle's underbody in one piece. The same thinking could be applied to aircraft. Instead of hundreds of smaller panels that need to be riveted together, a few megacast parts could form the backbone of the plane. This doesn't just reduce production time. It also removes opportunities for human error, cuts labor costs, and ensures that every single unit comes off the line with nearly identical quality. That consistency matters in aviation, where reliability is non-negotiable. But modularity extends far beyond the frame. Tesla is leaning heavily on shared components across its ecosystem. Batteries, inverters, and motors designed for electric cars or trucks can be adapted for aviation use. The logic is straightforward. If you're already producing millions of battery cells for cars, not use the same chemistry, the same packaging, and even the same thermal management strategies for planes. By scaling up one product family instead of developing dozens of unique systems, Tesla can bring down costs across the board. The same applies to inverters and motor controllers. Airplanes, like cars, need highly efficient power electronics. Instead of designing something from scratch at astronomical expense, Tesla can pull from the tool chest it has been refining for over a decade. That cross-platform design strategy allows them to price the super-electric plane at a level that seems almost unthinkable when compared to traditional aircraft. And it doesn't stop there. Tesla's most overlooked advantage may be its software. In the car industry, over-the-air updates have become one of Tesla's calling cards. A car bought 3 years ago can receive improvements overnight. Whether it's better battery management, updated autopilot algorithms, or even new entertainment options. Now imagine the same philosophy applied to aviation. Instead of grounding a plane for days or weeks while new avionics hardware is installed, Tesla could push software improvements remotely, cutting downtime to almost nothing. Airlines or private owners would see a dramatic increase in uptime, which directly improves the economics of owning and operating these planes. After all, an aircraft only makes money when it's in the air, not when it's stuck in a hangar waiting for upgrades. Another key piece of the plan is service. Traditional airlines and private jet operators rely on an ecosystem of specialized service centers, each with its own pricing and labor structures. Tesla intends to integrate service directly into its own network, much like it does with cars. That means standardized parts, centralized logistics, technicians trained in Tesla systems who can work seamlessly across vehicles and aircraft. By owning the service pipeline instead of outsourcing it, Tesla gains control over both cost and customer experience. Downtime shrinks, expenses drop, and trust in the product grows. Of course, building the plane is only part of the equation. Tesla also has to think about where these aircraft will be charged and how quickly that charging can happen. Here again, the company has a unique advantage. It already operates one of the largest fast-charging networks in the world. That network can be adapted for aviation. With megawatt-scale chargers capable of recharging planes and turnaround times competitive with refueling, the goal is clear: eliminate the argument that electric aviation can't keep up with the tempo of modern travel. If a plane can land, unload, recharge, and reload in less than an hour, it begins to look like a real replacement for short-haul regional flights. Factories play an equally important role in the cost equation. Instead of a single massive plant producing a trickle of planes, Tesla may opt for multiple strategically located factories that use the same standardized tooling. This approach allows for local production, reducing logistics costs and letting Tesla scale quickly in regions where demand grows fastest. The lesson comes straight from Tesla's auto playbook. Giga Shanghai, Giga Berlin, and Giga Texas showed how replicable factory designs can accelerate global rollout. For planes, the same strategy could create regional hubs that churn out aircraft while adapting to local regulatory and operational needs taken together. These strategies point toward a future where the super-electric plane is not just a flashy prototype, but a real, mass-produced product. The affordability of $79,979 doesn't rest on wishful thinking. It's the result of stacking every cost-saving measure Tesla has pioneered in other industries and bringing them into aviation. The combination of megacasting, shared components, over-the-air software, integrated service, global factory footprints, and an expanding charging network creates a blueprint that could realistically bring this aircraft to market without collapsing under its own expenses. It's a system designed to solve both the production bottlenecks and the operational headaches that plague current aviation. But the story is also about what this means for travelers. Imagine booking a flight and knowing your plane won't be delayed by fuel shortages, skyrocketing jet fuel prices, or endless maintenance checks. Imagine knowing that the aircraft is monitored in real time by Tesla's software. It's constantly optimizing performance, and that upgrades are pushed directly without waiting for the next scheduled service. For passengers, that means more reliable schedules, lower fares driven by lower operating costs, and the possibility of entirely new routes that make short-haul air travel far more practical. For operators, it means predictable expenses, reduced downtime, and a technology partner in Tesla that's continuously improving the product long after it's delivered. This brings us back to the broader picture. The aviation system, as it exists today, is weighed down by fuel costs, supply chain complexity, and old ways of doing things. Tesla is proposing to simplify, streamline, and scale the very same recipe it used to disrupt the car industry. If it succeeds, the implications are enormous. Airlines could face direct competition from a manufacturer that doesn't just sell planes, but also provides the infrastructure and service ecosystem around them. For Boeing and other legacy manufacturers, this isn't just another competitor. It's a complete rewriting of the business model. And for travelers, it could mean the end of an era defined by late flights, high fares, and endless frustrations. The Tesla super electric plane at $79,979 isn't just an announcement. It's a challenge, a test of whether the aviation industry can adapt to the future or whether it will be disrupted just as the auto world was a decade ago. The production plan shows how Tesla intends to cut costs and accelerate output by borrowing from everything it has already learned in cars, trucks, batteries, and energy. It's a plan built on numbers, efficiency, and relentless iteration. And it's one that could very well mark the beginning of the end for the old order in aviation. If you've been following along and you want to see more clear, numbers-driven breakdowns like this one, don't forget to subscribe to WestTech. We're working to reach 219,743 subscribers, and every click helps us bring more content your way. Turn on that notification bell so you never miss an update, because the future of travel is